All right,
Hello.
welcome everybody to another episode of Labs Talk.
Hello, everybody.
Again, Sven, that's me, and Andreas,
That's
and
me.
we have an exciting guest. But before we go there, what have you done last time?
Like every time, let's recap a little bit. We did sit together. We looked back into all of Q1.
Why did we do that?
We had a gap to fill. One of our guests got sick, unfortunately. We planned to talk about sports, technology in sports a lot. We had somebody planned from the Munich startup ecosystem. We were planning to talk about the startup ecosystem and the network he has in sports and the technology.
So we wanted to talk to Thomas from Unternehmertum, right, here in Munich, but I guess he got sick, unfortunately, and we can still repeat it at some point, of course, right?
Anyway,
so at some point we'll probably have this in Labs Talk.
That entire series on sport that we were talking about so much and that we put so much effort in, that didn't turn out the way we planned. We had two really fantastic episodes, but all the rest seemed to fall apart.
I also had the feeling for sports, these must be so extremely healthy people, they will never get sick, right? But exactly the opposite was true. I think out of 6 planned episodes, we're able to do 3, I believe, right?
Yeah.
And so,
but
anyway.
Enough of that. Recap. What did we do instead?
Well, instead we had a chit chat, right? And we talked about all things in life and a lot of sports, I believe, also what we do personally too.
Yeah, but one thing in particular that we filled that gap with AI, and in particular Agentic AI. We had Shardul around already.
Sure.
He told us about use cases in CX in particular.
Exactly. I mean, I just was speaking about the last episode that we filled up. That was the chit chat, right? But before we already had Shardul on, right? Of course, with he's the CTO of SAP CX, and we talked a lot about Agentic AI from a CX perspective. Interesting use cases from customer experience. And I think this also leads us very nicely to our show today, I believe,
and we're
right? So
super thankful for Christoph and for his flexibility. We super value his flexibility to come on our show today and share his academic perspective on Agentic AI today, right?
Perfect. But before we bring him on, so he's a Christoph Spanagel that we bring on in a second, senior data scientist at SAP Research and Innovation. And welcome, Christoph. How are you doing?
Welcome, Christoph.
Hello. Yeah, doing great. Thanks for having me.
Perfect. And you're joining us directly from the mothership in Waldorf, probably, right? If I see this correctly.
Exactly. I got a cozy meeting room today. Usually I sit outside with the other developers, but got a quiet room today.
Very nice. Nice.
It's the right environment to have this interview type of atmosphere, right?
So, last episode, or the last episode about Agentic AI with Shardul was, I think, a high-level overview, and we also talked quite a bit about features and potential of Agentic AI. And I think for this episode, with you as a researcher who really comes from years of AI and also Agentic AI research, we really wanted to do a deep dive on Agentic AI and explain some of the, I would say, fundamental concepts and technology behind it, and what even is really meant, and what are the potentials of all these autonomous agents that we're talking about. So, should we start with maybe a kind of a warm-up question, because most of our listeners probably already played with Agentic AI, but Christoph, how would you say, what is the big difference between agents and bots, for example? Because we probably all know this from different commerce websites, that we can now basically, chat directly with a bot or type some messages into some input boxes and we get some kind of answers. Is this Agentic AI already, or is this a bot? So what's the difference here?
That's a good question. Maybe we split it in two, like what's the difference between an agent and a bot? And then a little bit about is something an agent, like what is an agent, or how can I maybe think about that and classify that? Okay, how are agents different than bots? The way I would classify a bot, it's a predefined sequence of actions with a predefined set of inputs. And when you execute it, the same flow will be executed every time. There's nothing changes in the sequence of actions during its execution. And no matter if the environment changes or not, the bot will do everything every time the same. It will follow the same rules, the same steps it was programmed to do. How does that change with an agent? An agent gets a task and then uses an LLM to figure out what the next step or what the sequence of steps is to take. So when the environment or the task changes, then an agent has the ability to adapt to those changes because it predicts what to do based on what it sees of the environment, and then is able to make somewhat flexible decisions. So that's the difference between the bot and an agent. So agent uses AI to determine the sequence of steps, and a bot has a predefined sequence of steps.
With that, let's maybe take that question a little bit further. With that insight, are you able to outline the main characteristics of such an agentic AI, to give it a couple of bullet points?
Sure. Okay. I mean, characteristics of an agent. I think a bot maybe doesn't do planning and reasoning and tool calling. So those would be the main characteristics maybe of an agent. So agent, maybe this is a good time to kind of show the little image that we have prepared, because I think that would then allow to easily explain this and also kind of follow along for listeners.
If you want, I
viewers.
can do that actually, right?
That?
Yeah, I can.
So we have this image here. Let's
perfect.
Bring that on.
Perfect, because then that will make it very easy to talk about the main characteristics of an agent. All right.
So here we go.
So here is this image, and we'll zoom into that a bit. Yeah,
perfect.
Awesome.
I can even hover over that if I want to. Okay,
yeah, exactly.
Maybe that's not necessary. Cool. Then, a little image. We have 4 boxes. One is the user, one is the agent, one is called tool, and then there's one LLM. If we quickly use our imagination, the first chatbot, there was just a user interacting with an LLM. So user would send a request, LLM would send an answer, right? Nothing else would be happening. And now what makes up an agent? It's the agent box and the tool box. And what happens inside those I would then kind of explain as the main characteristics. So if a user gives a task to an agent, the agent would first perform a call to the LLM to maybe define a plan or figure out what would be a useful first action to do to solve the task. So for example, if the task is write an email, right, then the plan could be, okay, I need to find a header for the email, I need to find some content, then I need to find a recipient, and then I need to send the email, right? So that would be a sequence of steps. And maybe the LLM in the first instance would then print out those sequence of steps, right? And then one of those steps should then refer to a tool call, right? So if it's, I don't know, find sequence or find a subject or a headline, then maybe that would be another call to an LLM where the LLM will say, oh, the headline for the email is podcast tomorrow with Andreas and Sven, right? And then the agent would go ahead, okay, now I have a headline, now I need to find the content, and then it would go to your, like it would perform a web search, what's the new topic for the podcast, then it would retrieve the result of the web search, right? And here I mentioned web search or sending an emails, those would be tools, right? And so the agent would first come up with a plan, so that would be one call to the LLM, and then it would have a plan, and then there would be another call to the LLM for like, okay, what's the first tool call that we need to do? And that would happen in an iterative sequence. And so these are the main characteristics of an agent, this planning and then reasoning and then tool calling. Maybe what is reasoning? For an LLM, it works better if it produces more output than simple output. So if it, for example, before has the ability to write a bunch of text to itself about what the task is, that helps. So that's reasoning. So planning, reasoning, and let's call it acting or tool calling. Those two would be synonyms.
But I still would like to come very quickly back to the first question, like the difference between chatbots and agents. If I understand correctly, a chatbot more like is like a workflow engine, basically, right? So because if you think about a customer experience chatbot, right, it might also first try to figure out, is this about an order, for example, so I need to use my order management system to retrieve an order, or is this about a customer complaint, then I go into the ticketing system or so. But if I understand it correctly, the agentic AI here basically, or an agent, is basically fully open, but it also depends on the tools that it has accessible, right? So if an agentic AI system only has 3, 4, 5 APIs available, it could actually on the outside look very similar to a chatbot, I believe, right? Isn't that the case?
Yes, exactly. That's also why I chose more like an RPA bot or something rather than a chatbot, because a chatbot from the outside would look very close to an agent.
Yeah. So I guess for agentic AI systems, then it also really means that it makes sense where you actually really can use the creativity of such a large language model, right? Otherwise, if you don't leave it, if you don't have it, keep it flexible, then you almost don't need an agent, basically, right? So you need to keep it flexible for flexible tasks, basically.
Exactly. So maybe that's the next question to talk a little bit about when to use an agent and maybe when not, right? And the main point you mentioned there, that's a really good one, right? If your case allows for some form of creativity, and that's actually a feature, then an agent is good. If creativity is a bug, then probably you should stick to bots, right? Because then you only allow a certain set of flows and you want to allow the software then to only use those flows, right? Why introduce creativity into a system where no creativity should be used? So that's
a very different question where creativity can help. But let's skip that for that episode, maybe. I'm wondering, while listening to you, Christoph, I'm wondering, you touched a few of those things already, but maybe it makes sense to talk about challenges when implementing all of that. Like in particular, when things become creative, I can imagine things may become difficult to implement. And what are really the things that one has to consider when implementing an agentic AI system?
Yeah, also a good question. So the basic concept, as you can see on the image, that's rather simple, I would say. So something like this you have implemented rather quickly, right? You just have some system that can iteratively call an LLM, and you have a parser that would then parse the responses and map them to tools that are available. Then you execute the tool call, and you show the response again to the LLM, and you do this in a loop, right? Something like this you have quickly implemented yourself. The complexity then goes more into nuances like what if the agent has to handle a lot of tools, or what if the agent has to be able to handle very long conversations, or what if your tools are very complicated, and so on. And how do you integrate with a lot of these different, I called them tools, but Sven, I think you mentioned it before, essentially those would be APIs. Like tools are functions that other softwares do for you, and those you usually call via API. And to deal with some of the complexity that I just mentioned, like handling a lot of tools, having some form of agent memory to remember like long conversations or past conversations, and also integrating with a large variety of different tools that can be called via APIs. For that, we would use frameworks usually these days. And frameworks, I think you can kind of categorize into, or maybe frameworks you can categorize into two different boxes. And the third box would be that we implement everything ourselves. And that's usually where we in research start. We kind of want to understand the raw fundamentals. So I would take the picture you see here and then just go implement that in code and see kind of, where does it work, where doesn't it work? And then maybe you quickly find some of the challenges that we talked about, and then you would go and maybe use a framework for some of these things. And then the first framework you would use is usually a pro code one. So you still have to write some code, but you don't have to write all the code. Prominent examples are like LangChain, or now Hugging Face has a library called Small Agents, and Crew AI also. Those are like frameworks that allow you to implement agents, but you don't have to write everything. You don't have to write the full model client yourself. You don't have to implement the entire like tool abstraction. They have probably some standard libraries for tool and so on, and also for agent memory, like how to handle very long conversations. You have some abstractions for that. And then for people that don't write code at all, there's also no code tools. So then really the only thing you do is like in a UI, you would kind of drag and drop which tools you want and sort of define some outlines of your agent. I just thought of another example that you have to think about. How much iterations, how much of running in a loop do you allow your agent, right? Because it's AI, potentially it will run forever. If you give it a very complicated task, I don't know, find the meaning of life, and then it will go on and use its tool and run forever, right? Those constraints, those things, frameworks will abstract them away from you so that you don't have to think about
that. That will ultimately produce an answer. Just we know that from the Hitchhiker's Guide in the Galaxy, right? That where the entire Earth used to be a supercomputer that calculated for a very long time.
Before we go deeper into that, and I can see I have multiple questions in my head now, actually, when it comes to how many tools an agent can talk to, for example, and maybe also when it comes to security and stuff. On the previously shared image, there was also this abbreviation RAG, Retrieval Augmented Generation. Can you maybe also quickly shed some light on that, what it actually means and why this is so useful?
Yeah, that's a good point. So maybe let's quickly think about sort of the evolution of LLM applications. LLM boomed in 2022 with ChatGPT, right? And the first application that we all used, it was a web interface. You had a text box, you could type some text in and you would get the response. And it would be amazing because it's something you never thought an AI would be able to come up with. It basically had the knowledge of the internet trained into it. But quickly people realized its boundaries. It was very bad in like domain specific knowledge. If you had some knowledge base that your company has acquired or something, or you're like a lawyer and you have a huge repository of past cases or something and you want to chat about that, that wasn't possible with ChatGPT. And this is when RAG came in. So it solves the problem of giving the model access to knowledge it didn't have by searching first in a knowledge base and then retrieving the rough outlines of what's relevant to the question and then sending that along with the question to the model and then responding with an answer. How is that relevant for agents? For two cases we just talked about, this could be a potential solution. And RAG stands for Retrieval Augmented Generation. So retrieval, I retrieve rough context from a larger knowledge base, and then I augment my prompt with it, my question with it, and then I generate an answer. So that's why Retrieval Augmented Generation. Why is that important for agents? For example, if an agent has to handle very long conversations or needs information from past conversations, I can store them, and then I can use Retrieval Augmented Generation to, before I give an answer, before I let the agent come up with a plan, I retrieve some of the past conversations and I send them along with the request to the LLM to make a plan. That's one option. The other one is for tools, right? If I have a huge amount of tools, I can also make them searchable, right, via a description or something. And then I would retrieve the most relevant tools and then just send them along with the request for the model to come up with one tool call or a plan. So this is what Retrieval Augmented Generation is, and its use is basically to enable an LLM to access, let's call it proprietary or domain knowledge while making generations.
Maybe just to put that into context, we put a little sticky there that said vector databases. And for my understanding, that has been something different. But since we put it there, let me ask that question. How does that relate to Retrieval Augmented Generation?
Vector databases is what allows us to do the retrieval. Like a vector database is a way to turn text into something you can search, because how would you search text? Maybe with keywords, but that's not very efficient, right? So it's much more efficient. You take sentences or paragraphs and turn them into vectors, store them in a vector database, and then you would come with your query, with your question. You also turn that into a vector, and then you can match which vectors are closest to the query you have. And this is how you do the retrieval. So that's what vector databases do. They store vectors, and they can sometimes calculate the distance between two vectors and then sort the database according to that distance.
Cool. So if we come back to these agentic AI systems, right, that have, let's say, multiple tools at their disposal, and they can reason and they can come up with a plan and then call all kind of APIs to do things. The immediate question I had just 2 minutes ago or so was, how do we safeguard systems in this case, actually, right? So how do we, for example, I mean, in the easiest implementation, I would probably just take all my tools, stick them into some kind of agent front end or so, and tell my customers or tell my people basically, hey, use my agent. But that would also basically open up everything every API can potentially do to this agent. And I'm not sure if that's such a good idea. So how would you restrict usage, and how do we kind of create different roles and maybe also keep the human in the loop when it comes to really severe actions an agent might take? Is there some research on that?
Okay, I'm not sure if I can quote research, but I can just kind of give you my feeling, right?
Yeah, fair enough.
And I think there's kind of two things to consider. And one is, of course, the builders, the people that build agents, they have to like think about what's a good, probably a function that deletes the entire database, not a good function to give an agent, right?
Yeah.
Things like that, I think, should be in the hands of the developers. And yeah, best guidelines and how to do that, I think we still have to figure that out. I think it's not super clear. I mean, of course, you can make some agents that are read-only, but then it's questionable how useful are they, right? Of course, if you limit them, less useful. And the second part is on the users itself. And there, I think, it will be somewhat similar to maybe how we experience autonomous driving cars, right? Where, okay, maybe now they could kind of drive alone, but you still have to watch and keep your hands close to the wheel and so on in a lot of cases. So maybe that's also how we will see it in the beginning of the agents, where they will do a task for you, but you are still responsible for the outcome, and you would still observe the agent at least every now and then. Maybe you don't need to be as focused as if you were doing it yourself, but I think that's maybe two ways of how we can, sort of safely start to develop agents. And then I think this will also show the developers then, and kind of in the end show, what agents are good agents because people trust them and use them, and what aren't because people are constantly interfering or having lots of trouble. I think it's at the moment pretty hard to beforehand say, oh, this is super ethical and this isn't.
Christoph, just to interpret what you're saying and to reflect what I'm hearing. So you're saying it's exactly what we are talking about. Agentic AI is a technology to make us all more efficient, to help us to work more efficiently, but it's not like it's taking away jobs. And with that, you're saying it's super safe to give those agents that we look at today, to give them the permission to do so, and as a user just to observe, to have them work on our behalf under our oversight and give them the permission to do so. That's okay?
I mean, that depends on kind of I think that's not a yes or no question. I think that's it depends question. I'm saying the way to figure out kind of what is okay and what is not. Some brave people will get agents and then start using them, and they will be like, I'm okay, I will be responsible for the result of this agent, but it helps me, right? And then this is how you sort of figure out what good agents are and what not. And of course, I kind of have to say that, right? I come from an innovation team. We get an idea, we build it, we ship it, and then we learn from the results, right? Of course, if you're doing something really big on the scale of the entire world, like if you would be now the one agent company, you should probably think a little bit more about that beforehand. And of course,
indeed, I didn't really mean to make it a yes or no question. I just realized when you gave that back.
No, but you have to answer yes or no.
No, totally not. Like again, just taking back. Thank you for that answer. I take you're on the very optimistic side in that entire field.
Of course, I have to be. Maybe for okay,
come on.
On the ethical side of replacing humans, I think that's the fear people have since the beginning of technology. There was always oh my God, this will replace us all, right? And I think maybe I should be one of the most scared people, right? I'm a coder, and the LLMs are incredibly good at code. It requires a lot of creativity, and you already automate a lot of things, right? But I'm not really worried about it. I kind of like coding with AI, right? I like sort of having an agent that kind of works with me, right? I enjoy that. It makes me more efficient. I'm not really that afraid of it replacing me, because also while I'm using it, right, while I'm somewhat trusting it, I see all of the mistakes it does, right? And I mean, I don't know how fast they will be fixed, but then I think there will be new problems coming up that require what humans do that agents kind of can't do, which is on a different level of adaptability, right, that humans
Andreas, before we jump into the next topic, I would like to have an extra question about agents again, basically, and specifically about the permissions we give these agents. So in the pre-chat, we talked also a bit about, we have all these APIs, and in technical terms, sometimes we create so-called integration users, and then some external systems use an API via this integration user. But I think we discussed also that typically an agent would act in the name of a user. So you would basically authorize the agent to act in your name with your permissions, with your account, basically. Is this what it's really typically done? And this is how you see agents working, basically, that they really kind of act alongside a human being with the same permissions?
I don't know if this is what's typically done in the terms of this is what most of the frameworks use. I think some of them don't even really cover this problem. I think this is a good first solution for the projects we work on, right? Because then what you need is a very brave user that you tell, okay, please, you have to be responsible for the actions of the agents, because I think the model providers, they are not, right? Of course, they are caring about safety and so on, but in the end, they don't know. Like, it depends so much on what input you send to the model and what the output is, right? So they can't take full ownership of the decision an agent makes. Similar, the model builder can't, right?
Yeah.
To an extent, it can restrict what an agent can and can't do. Like, it can forbid the delete all command of the database, for example, but it cannot cover everything, right? So
Yeah.
for some aspect, the user has to be responsible, and for that, then it also makes sense
Exactly,
that the agent
right?
has
It
the
is
permissions
really,
of the user, right?
I think it's really a question of accountability, right? If we have an integration user and the agent uses this, let's say, integration user's API in the end, then of course, I know that this 1, 2, 3 human beings are out of the loop basically when it comes to be accountable. But if of course an agent is acting in my name and I'm supposed to watch it maybe, right? Then whatever the agent does, it's my accountability. So I might be faster in solving some tasks, but if something goes wrong, I also have to take this onto my account basically, I guess. Yeah.
Yeah, I think this is where just a lot of building and testing also will learn. For some agents, if you see that the statistics, they work so well that you can trust them, then maybe, in a future version of this agent, you can give it the permissions of an integration user because you have understood it well enough. But that's one of the big differences also between, like, let's say, bots and agents, right? They are not deterministic systems. And if you're trying to make them, then maybe you are better off with a bot, right? So, but at some point you will have understood the agent maybe well enough that you know what to trust it with and what not. But this is not you can't really write unit tests for agents. It's more of a kind of statistical thing.
Wow.
Yeah, everything. Got everything. I'm just trying to get back to the talking points we had here. Maybe now that we had this conversation about what works, what does not work, let's move this slightly forward, and that's probably a very quick discussion, Christoph. I know we had that conversation when we prepared this, but let's dive into potential applications of agentic AI very quickly, where this research happens for a reason. And with that, what is it that you have in mind, or that others in the industry have in mind for these agents?
So I think at the core, the main capability we have is still a large language model trained on a large variety of text of the internet and a bunch of conversations we have had with it over the past few years, right? So agent cases that work with a lot of textual data are probably the best ones, because you are playing to the strengths of the model and you are playing to domains where generally creativity is okay, right? Because if you think about text cases like responding to an email or writing a job description or writing back to like solving a customer case and explaining them what went wrong, there's some creativity allowed, right? There's not only one correct answer. You can phrase it in different ways and so on, right? So I think those cases is where agents will work somewhat well. And then also if the tools that the agent can use are somewhat simple to use, I think that's also important. So for example, a send email tool, it's could be very easy to use, right? You have a header, content, and a recipient, and that's the 3 values the LLM has to decide on what to do, right? Versus if you have an API with 50 parameters or something, and none of them are described very well, then that's maybe not a good agent case to use.
Yeah.
Then maybe you have to think about how you want to abstract this, right? So I think those 2 factors, maybe with a third one, that's the complexity of the tasks, right? So if the complexity of a task doesn't really require, like human level intelligence, but maybe something a bit simpler, it's roughly about text, things you can represent well in a textual manner, and the tools are somewhat simple. I think those are the first cases you wanna look into, and then go and learn from there, while these models also keep getting better and keep also working with new modalities, like for example images.
Okay. I think I need to ask again about AGI, right? Artificial general intelligence. Are we getting there? I mean, I think with large language models, right, we've all been really surprised how cool it is and what they can do, basically, what great answers they give and how they write blog posts in one go. And now with agentic systems, we're really taking this to yet another level, basically, right? And the more stuff we connect to it, the more powerful it will be. So when AGI?
I mean, I don't know. I don't like the term too much. I think it's somewhat useful, and I would describe it as, okay, when a system reaches human level intelligence, but then how do you define human level intelligence? So I think this is a very difficult question to answer, and I know kind of tech CEOs like to do it because it creates a big fuss and whatnot. One of my favorite researchers is Jan LeCun, and he says, as long as we are like using large language models, we will never really achieve AGI. And I'm kind of with him on this space. He has a very compelling argument that's like, okay, we show these models now, everything in text form, right? But the world, like what we humans interact with, is so much more than text, right? A lot of it is visual, haptical, and so on. And there's so much more information that I think we don't really know yet how to teach that to models properly. And then also something that's very important for me is like the notion to learn at human level speed, right? An LLM needs to run for weeks, months on thousands of GPUs. If you show me a new problem, I don't know, I can learn that in hours maybe, right? So I think
depends on the problem.
Yeah.
Yes.
It depends.
Let me
on
find
how
a problem for
define
you.
AGI.
But let's maybe then stay a bit. So I mean that's part of our looking into the future section, all right. So maybe AGI is a bit far out, and maybe it's also not really meaningful to discuss that. But let's talk about other things. So in the area of agentic AI, what are the things you would see coming up that are getting more interesting and that's guiding your research a bit?
Yeah, that's a good question. And I think there the trend is, okay, as we kind of discussed in the beginning, like bots were restricted, agents are more free, but how free, right? What's the degree of autonomy that you want to give an agent or that you are able to give an agent? And currently the restriction would be, okay, you kind of has to be text-based and the tools have to be simple. So I think what's next is these restrictions will be loosened. That maybe the case doesn't have to be purely text-based, or maybe the tools don't have to be so simple. Because kind of three trends I'm observing is one is these, maybe you've heard it from Anthropic, they call it computer use, or some other researchers call that GUI agents. That's also something I have been working on, where a model, instead of having a fixed set of tools, would just use a computer screen the way a human would use it. So you show it an image of the screen and you ask the model the task, kind of, I don't know, if you're in an S4 system, you ask it to create a cost center, then it will kind of click on the app icon and then type in some values and click on submit, right? And then read the responses from the user interface. That just makes them more like easily usable, right? Because now everything that has a computer screen, an agent can interact with, you don't like need an API or so on. So that's something that I think kind of interesting. And it also touches on this new modality of using images for agents. That's one thing I see in the future. The other is agents that use, instead of tools directly, that generate code, right? Because if you think about it, an API call is also somewhat like code, right? You write a payload, maybe a JSON, and then you write in Python some request.post, and then you do something, right? But you could also write any other function that this programming language allows you to express. So instead of the agent reasoning and then performing tool calls, it would reason and then write code snippets and execute them.
Okay.
Right. So that's more freedom, right? Because now the agent can do everything that's possible with that programming language.
It's amazing.
So
yeah, and again, it could also write like a huge loop and never get out of it, right? So it also needs at some point needs to be restricted, which brings up again this question of ethics and permissions and stuff like that. But yeah, that's interesting where you see things going actually. Wow.
Yeah, so this is kind of good, right? You're taking it somewhat slow, you're figuring this out sort of in parallel, and then also, like that humans and agent can kind of grow together. And then the third thing that's interesting that's recently come up is this whole notion of reasoning models, right? I don't know if you have heard it, like OpenAI has been talking about their O1, O3 and whatnot, and the DeepSeek R1, and that they have been trained with something called like reinforcement learning. And that's also partially what I mentioned in the AGI discussion, right? You want the model to sort of kind of learn on its own, and maybe it's not faster, but at least like it's learning on its own, right? Versus how most models are trained at the moment, to the largest degree, it's called supervised learning. So they exactly see kind of what text to produce. And then whenever you give it a new answer, they kind of look of what has been shown to me before, and then they generate something out of that, right? That matches well to your request. And with this reasoning and training them via reinforcement learning, you wouldn't show them exactly what text to like learn to produce, but you would kind of let them generate some stuff and figure out on themselves what's good text to produce, right? And this is currently used for reasoning. So these models kind of learn to reason on their own. They just get a final goal. In the case of DeepSeek, it was solving a math problem. So they get a problem and the answer is hidden to the problem, but then the model kind of can generate a large reasoning. So it can like prove the mathematical problem however way it likes, if it does it in Chinese, English, Spanish, or whatnot, or whatever symbols it wants to use. Maybe it wants to do it with dots in binary, or it doesn't matter. It's on the model's kind of choice on how it solves that. And then in the end, it will produce a result, and you will check the result. Is it correct or not? If it's correct, you give it good reward. If it's not correct, you give it bad reward. And then sort of the model learns on its own how to reason to correctly solve math problems. And that, of course, can be applied to more domains. And that's kind of what reasoning models are and what makes them special, that they sort of learn based on an objective and not based on concrete examples they have been shown of like text to produce.
So are these reasoning models typically being used for agentic systems then? Would it also be possible to create an agent with the open AI model that was published a year ago, so which was not a reasoning model?
Yeah, okay, so I think the difference that's happening is, okay, previously you had to ask the model specifically to reason. I think reasoning models, they will just reason.
That's just built in now in a few extra loops behind the scenes, basically. Okay.
That's the difference. I think now you are building the loops, the extra loops to make the model reason kind of, right? And in the future, the model just does that because it was trained to do that. You don't need to, the loop is kind of, in the model, the loop is always there. The loop is there today because the model produces a word at a token at a time, right? So
I'm just wondering, right? So if all this is hidden behind an API, how would you even figure that out, right? I mean, who knows what's happening behind the scenes, behind the APIs of OpenAI? How many other systems? I don't know.
Yeah, I guess we have to have a couple of more conversations on that topic.
Yeah. You should get someone from Hugging Face to talk about that. I also like their kind of opinion about OpenAI is called OpenAI, but they are developing closed AI, right? And I think more AI should be developed open, because this also solves some of the ethics and security considerations, because if everyone can see everything that's developed and look into the very least bit of everything, right, it's way less likely that the outcome is going to be a weapon, right, or something like this.
And thanks for mentioning some of the other providers like Anthropic, for example.
Absolutely, and thank you for the pointer. I'd suggest we pick that up as an idea.
Yeah,
and
totally.
At that point, we thank you for all the insight and for sharing your expertise. Thank you for being on the show, Christoph.
Perfect. Yeah.
Thanks so much for having me.
Thanks so much, Christoph. Talk soon.
Ciao.
Bye-bye.